Hi, and welcome to the Exponential View podcast. I'm Azeem Azhar, the host of this podcast and the producer of the newsletter of the same name. This is the last podcast of 2018, so I want to take an opportunity to wish you all a very successful 2019. I'm very excited about my guest on this episode. It's Jack Clark, the Director of Policy at OpenAI, a non-profit research group looking to build a path to safe artificial general intelligence. First-time listener, you might want to know that this second season of the Exponential View podcast is all about the political economy of technology. In previous episodes, I spoke to economists, investors, entrepreneurs, and policymakers shaping the future of society and technology. You might want to browse through the archives and subscribe to receive a new mind-expanding conversation each week. For the next few weeks, the Exponential View podcast is sponsored by Spotify. I'm a massive fan of Spotify, and they've now added another killer feature, a podcast hub, where you can get your favorite shows, including this one. So next time you launch Spotify, search for Exponential View and pick up the next episode there. Now, on to our podcast. Today's guest is Jack Clark, the Policy Director of OpenAI. In this conversation, we discuss the state of artificial intelligence, the geopolitics of the technology, and what monks and elephants may have to do with AI. It's really good to have Jack here. Hi, Jack.
Hi, how are you doing?
I'm well. Did I pronounce your name correctly?
You did. It's a simple one to pronounce, actually. So
J-A-C-K.
J-A-C-K, Clark. I'm also a famous baseball player, so
not
there's
that one
to contend with.
Perfect. Well, we're going to talk today about artificial intelligence. You're policy director at OpenAI. But when we were chatting about this conversation, you said you really wanted to talk about monks. So I'm going to humor you. Tell me about monks.
Thanks for humoring me. Yeah, so I've been playing around with this idea for a while about how to think about our world and artificial intelligence. And so I think this is as much a question about the communities of people building this technology as it is about the technology itself. And so the story that I've been telling people is hundreds of years ago, when you had the invention of the printing press, you had this community of monks who'd been stewarding civilization from their perspective pretty well through the Dark Ages and had been keeping knowledge alive. They had access to privileged information, privileged knowledge, and privileged institutions. Then the printing press came along and kind of messed everything up for them because it changed the dynamics of knowledge, who could participate in knowledge and what it means. I think that the AI research community is going through this period now where they're figuring out which of them are monks and which of them are peasants, and like which of them should be doing printing presses and which of them should be keeping information, private or messaging it carefully. And I think the reason why this is worth talking about on this podcast is that the way that society responds to the rise of AI is going to be conditioned by how much society trusts the people that make it. And so this decision about how you present yourself to people is going to have a real impact on what we do in at least the democracies with regard to artificial intelligence.
Well, normally what the historical experience has been is that the technology is often developed by people outside of the power structure, or people who want to step away from that power structure, because these technologies have a way of upending the apple cart and the status quo. And so you definitely see the priests not wanting to believe in the heliocentric model of the solar system.
Yeah, it messes everything up for them.
Messes everything up. So just thinking about this analogy with the monks, if you think about the AI research community, are they Gutenberg or are they?
Well, I think the way I characterize it is they were monks for a long time because they had to be. We've had multiple AI winters, just to tease this analogy and extend it to breaking point. That's kind of like the Dark Ages. Right. You have to keep that knowledge alive. You have small communities, NeurIPS, the conference which just happened in Montreal, that was originally a skiing conference where the small number of academics who knew about neural networks and brains would get together and do AI in the morning, then go skiing in the evening. They were a very small, close-knit community. And now they've found themselves in this position where, the printing presses have arrived, the community has quadrupled, quintupled in size over a very small period of time. And I think some of them are thinking about what their role is here. Mm-hmm. And I think that this can be good. Like, you need so you need different heterogeneous types of communities to make things happen in a good way. The danger here is that you end up pushing like new ideas out because you as a community want to control this thing that you feel you've kept alive for years. And so you view it as a uniquely delicate time when the thing you've kept alive for years becomes of mass interest to everyone and they're figuring out what they're going to do.
That is superbly interesting. That is a fantastic insight. So I'm just want to play that through with some other perhaps historical precedent. So the issue there is that as you say, the AI world was nowhere. It was frozen out. Everyone was interested in social and mobile, and there was very little progress seemingly. You've kept it alive. It's meant that you've probably had to reject a little bit of cognitive diversity. In other words, different ways of approaching the problem because you're just hammering away, chiseling away, and it's suddenly become important. I suppose one precedent to this would have been perhaps in the early days of the internet, in the late 80s and early 90s, the groups like IETF and IANA, people like John Postel, found themselves going from very, very graciously managing the infrastructure, the protocols, the ways of working, and then within the matter of a few years, having to contend with all sorts of different opinions and voices and developing new forms of governance. I mean, and that happened over the course of perhaps a decade, whereas this is happening over the course of 2 or 3 years.
Yeah, this is happening on a more compressed timescale. And just to go back to your point about the internet, if I recall correctly, there was an early community who hung out on IRC, and chatted with each other. And then there's this mythical day where I think AOL sent out loads of CDs that let loads of people onto IRC. And overnight, the community changed from this very, very small group of internet nerds to very small group of internet nerds plus everyone's like parents and grandparents who are typing in like how to get recipes for my dog. So they have to deal with this different dynamic. And so to your point, the speed of this transition is what's causing, I think, the tensions, where we see now that governments and society at large have realized that the tech boom that we're sitting in has got really serious. Companies like Amazon, Uber, Airbnb, these are all manifestations of what happens when you get really good, like networked capitalism, which is enabled by technology. And I think people are now looking to AI and they're asking themselves, what are the decisions we're going to make about how this technology will affect society? Because we can see around us that today tech is affecting society in a whole bunch of ways, some of which are like extremely negative and some of which are extremely positive. So it feels like there's this pressure on AI, which is different to like cloud or big data or other like big moments.
It's the hackneyed phrase is the perfect storm because you're right. When you look at things like Airbnb and Uber, you have these companies that exhibit network effects, but they do so at a time when we have a playbook for how to build network effects very well. Those very first early internet companies like Rise and 6 Degrees that were pre-LinkedIn, pre-Facebook social networks didn't really have that playbook. That playbook is now very well understood. There are product managers and marketers who've been through many cycles of this. So the business capabilities are there, but the network effects now generate the data network effect and that lock-in loop where you generate more data with every additional user. And that data is catnip or rocket fuel for AI systems. And so this particular software manifestation, which is machine learning, which gets better and better from data, does doubly well on network effects, which would already become really good at building in these winner-take-all markets that were pre-AI. So it is the conflation of these two themes that might explain why we're seeing this level of market take-up, but also that pushback by societies and people and governments.
I think that's a really important point you make specifically around how with data, these network effects become really powerful when you get to use the data and grow in scale. I think of this as like neo-feudalism. So to use another tortured historical analogy, in feudalism, you have castles, right? You have lords. You have the people that govern a group of people who get to live on their estate. The people are given some level of security, some level of service, and in exchange, they produce resources for the lord. Now, this is exactly the way that these platform companies work. We all get to like hang out on Google or hang out on Twitter. We get something for it, and in exchange, we give them resources. Now, the difference is that in feudalism, you'd like eat all the bread, you'd eat all the meat, and then you'd need to like keep the peasants happy and keep them doing stuff. In neo-feudalism, you never finish eating it. The data never goes away, right? You're constantly able to use it. And I think that the thing with AI is AI lets us compute over this now infinite pool of data which you can access. And we know that that's going to lead to supremely powerful, amazing things like really, really good medical technology, really, really good scaled up services for healthcare or for helping me figure out stuff about my career. But it's also going to lead to negative things. And so,
like all the power being with one guy.
Like all the power being with one person, you know, or you know, the way that we used to deal with feudal lords was they just got to hang out and run the country. And no one was particularly pleased about this state of affairs.
Right.
So what we have now is a society where we have mostly democratic institutions like governments, and we have feudal entities like large tech companies, and they're definitely running into each other. And so when we think about AI, it's like, what happens if we just take this and make it 10 times as more powerful?
I could tell, you know, the moment where we have to constantly use historical analogy because we don't have the words for our exact situation is great evidence of the fact that things are running away very, very quickly. Now, one of the things that you do is you run the AI Index reports. You just published the 2018 edition in December. And the thing that came across all the headlines was things are accelerating. If you thought they were fast in 2017, they're even faster in 2018. So I'd love to get your state of the AI nature right now. I mean, how would you characterize it?
Yeah. So I'll just sum up all of AI very briefly for you.
Let's do that.
Thanks for giving me the easy questions. Really appreciate it. So the thing with the AI index that we try to do is we try to analyze the progress of AI on technical metrics and also how it's impacting the world and evidence for it impacting the world. So what we found in this year's report is you see a tremendous growth in class sizes worldwide at places like Tsinghua University in China, you know, Berkeley in America, Montreal Institute for Learning Algorithms in Canada. You're seeing class sizes for preliminary AI courses designed to convert undergraduates into AI experts. Those are massively growing. And I think that there's a really big signal there, the signal being this is now what really smart generalists want to develop some knowledge of. And I think the moment you have that, you have a new generation which is going to understand this technology and build it in a really, really tremendous way. The other important signal, I think, that's in the report is that we did a series of analyses of like how the media talks about AI. And one thing that jumped out to me was we did an analysis with a company called Prattle of past Bloomberg conference calls. So conference calls from companies that are recorded by, you know, the Bloomberg data system. And we counted the mentions of big data, the mentions of cloud computing, and the mentions of AI. And the reason why we did this is we know that hype in big data and cloud correlated to massive economic decisions. It changed how companies invested in things, and they said these words to signal to their investor community, we care about this, we're on it. What we discovered was the peak for big data was pretty high. Cloud was kind of above there, and AI was basically double where cloud was, and it's still climbing. And actually, the signal that we can take from that when you combine it with things like growing class sizes, expanded shipments of robots worldwide, is that the economic sort of fabric that will underpin the next AI boom is being built today, and there's evidence all around us. And we also have a new generation which just massively wants to know about this more than any other subject, as far as we can work out.
And I think one of the reasons why it can do that is because of the investments in enterprise IT over the previous 25 or 30 years. I mean, we actually spent the 1980s doing business process re-engineering, where we turned squishy, arbitrary human processes into things that could look like value chains and fit neatly onto PowerPoint slides. And then we started to build IT systems like CRM and ERP that took over bits of those boxes. And then over the last 15 years, as we've built data lakes and moved processing and systems onto the cloud, we've created essentially a decent stack on which you can run learning software.
Yeah, exactly. So it's just to interrupt you, because I think this is
interrupt
really
you
interesting.
the whole time, please.
We talked before we started recording about how AI is composed of like data, algorithms, and compute. Now, what you just said is really interesting to me, because big data meant that we got the data piece. Companies like digitized loads and loads and loads of data. And cloud computing means we have the compute piece. We now have these places that companies have stuck this data, but have access to huge pools of computing power from Amazon, Microsoft, and Google. And now all we're really missing is the algorithms piece, which is kind of the AI. So at a meta level, the realities of business have also created like the ingredients for what you need to make AI autonomously, which I think is kind of funny.
Well, it is. I mean, it's funny. It also, again, we've got historical precedent for this. I mean, Carlota Perez has this model. She's an economist of the installation phase of technologies and the deployment phase of technologies. And the installation phase is building canals and laying down railroads. The deployment phase is the phase where applications build one on top of each other. Now, it's not a model that works perfectly, but it's a pretty powerful model for explaining why it seems to be the case that AI is going very, very quickly. I mean, I know that the CTO of Accenture has sort of publicly said that AI is the fastest growing IT trend he's seen in a 30-year career that's covered off CRM and ERP and cloud and a bunch of other things. A lot of this was kicked off back in 2011 because of a technical milestone that was achieved back at the ImageNet 2011 contest, where deep learning was used, and we got an algorithm to recognize objects in images substantially better than we'd been able to before. But now looking back on what that performance was, it was pretty poor compared to where we are today. What's actually happening in the state of technical performance? How should we now think about it? And what are the approaches that people are using to make these breakthroughs?
So let's deal with the senses first. So you've talked about vision. Like, we got vision. Vision works pretty well now. You can still confuse it. Like, if I show a computer a picture of a room with a table, it will say that room's got a table in it. And then if I stick a picture of an elephant in the room, it'll be like, that room has 10 bananas in it. And I'm very, very confused. So just to be clear, still a little broken, but for the most part, it works very, very well. What's been happening is we've been shifting into the other kind of sensory or cognitive domains. So language and the ability to model language is going through a similar boom now that we saw, I believe, with ImageNet in 2010 or 11. And the reason why this is happening is the ImageNet breakthrough was mostly a breakthrough, I think, in systems. It was, we have neural networks, but now what we really have is an ability to build a system that can leverage graphical processing units, GPUs, graphics cards, to perform neural network computations at large scale over this large data set. And so you create the system that lets you win the benchmark. Now we're building these very complex systems for scaling up the types of AI that we train. And what that means is that you can start to attack problems like language, where language, I think, goes to the root of consciousness. It's how you and I are talking to each other. It's very, very hard. Non-symbolic approaches, like neural network-based approaches, are probably always going to struggle with doing this in a sample-efficient or data-efficient way. But if you can just train large enough systems over large enough amounts of language data, you can start to get capabilities which are interesting. So there's a benchmark called GLUE, which came out this year. GLUE is exciting because it measures language understanding on 10 distinct tasks. So ImageNet was one task. 10 distinct tasks already tells you that the systems have got more advanced. And what we saw this year was a series of milestone results from OpenAI and then swiftly followed by Google with its BERT system that tremendously improved performance on this benchmark. And what that's telling us is we're now developing language systems that have multi-sensory capabilities and are multifunctional. And that's kind of neat.
I have the GLUE benchmark from your report on here. And just to give a sense of what the progress has been, a non-expert human should score about 90% on GLUE. In May 2018, The best AI systems were scoring about 66%.
Mm-hmm.
By October, they were up at 80%.
And that's big. That should actually make you lean back and go, hang on.
Yeah, I mean, if this had been ImageNet days, you would have seen that happen over 2 years.
Yeah.
But I mean, by ImageNet, I mean 2010, 2011, 2012. And we've seen it happen over the course of 6 months. Yeah.
Yes. And the other thing that I think is hugely significant and basically not counted today is the scale of the systems that we're training these AI systems on has grown tremendously. So let me just throw some numbers at you to give us a sense of what we're dealing with.
Yeah.
You know, OpenAI had a system that did well on a video game called Dota 2, sophisticated game. We were using reinforcement learning, so we needed to use a lot of computation to go between the simulator and our algorithm. That used on the order of 100,000 or 200,000 CPUs and several thousand GPUs. I'm now regularly reading papers from labs like Alibaba and Tencent, you know, the big Chinese companies, which say, oh, we ran this on 3,000 GPUs and, you know, 50,000 CPUs. DeepMind's Alpha Go and Alpha Zero work, according to an analysis performed by OpenAI, probably used one of the largest single amounts of compute training that we've ever seen. So the things that we're using, the factories that we're making AI out of have got really, really, really big. And I don't think people understand what it means when you have a really big factory that's inherently multi-purpose. So there's no real specific engineering to these systems that stops you from training it on another task. So the system we built at OpenAI to do Dota, we also used to train a robotic hand, right? So one factory, two very different things come out of it. And I think that tells us that when we think about the economics of this, that as soon as we realize productive economic applications, there's infrastructure waiting to start making that and turning it into reality. So the speed of which it's going to make its way into the world is going to surprise people as well.
The marginal cost decline is pretty close to zero, except for the power.
Yeah, the power is extremely bad. Let's be clear.
Well, I was just reflecting on the fact that you know, the human brain playing Dota requires about 25 watts.
And a Coke, but yeah.
And a Coke, and maybe a bit of pizza, and 200,000 CPUs and 7,000 GPUs is a little bit more electricity required to drive.
Quite a lot, yeah. I mean, there's a bit of a way to go there, I think is a good way to phrase it. But I mean, this leads us to kind of a couple things which are interesting to me. Thing one is sample efficiency. So, you know, wouldn't it be nice to have AI systems that ran on 25 watts or whatever? I think that we might get close to there, but first we'll have to build the tremendously large-scale kind of wasteful systems. What's interesting to me about the wasteful systems is that we are still gaining capabilities. So it may use, like, frankly, an embarrassingly large amount of computers, but if it can do something like automatically categorize the faces of every single person in an urban area, is that interesting? It seems interesting. And we don't care about the underlying efficiency of this system beyond just the economic cost.
Yeah, no, I agree with you, actually. I mean, I don't think there's a particular issue in this being computationally expensive or expensive in terms of its use of RAM at this point, because we're trying to understand the parameters of what's possible. It was a lot more expensive to launch rockets in the 60s than private space explorers are capable of doing 50 years later. So we have to push out the limits. I suppose it raises a couple of questions about what kind of firms can actually compete, and to what extent does the ability to throw 200,000 CPUs at a problem provide the wrong sorts of constraints to engineering or algorithmic optimization, right? If you can always just throw more resource at it,
you're just going to be lazy.
Are you? But you're much closer to the community.
No, that's true. You will be lazy, not to just offend the entire community. I mean, we see this, right, where we like to scale things up. You know, so does DeepMind, so does Facebook. Everyone does. Most of the researchers like to, because we have these somewhat generic algorithms which you can feed large amounts of data to, and they seem to get better and better. Or if you're in a domain where you need compute, same applies. It does create poor incentives for stuff like creating more efficient things. And I think that this should concern us because it's tied up with the fact that companies and sort of private enterprises, which I'd count OpenAI as, but we're a little funny in our configuration, have sort of taken over large chunks of AI research. And I am seeing the community split, where we have people who are at MIT who then come to OpenAI say, wow, you have a lot of GPUs here. Now that terrifies me, because if you're at MIT, you should have access to a huge amount of GPUs as well.
That's what it was like when I was at university, right? The most powerful computers were in NASA, in the NSA, or in the university data centers.
And so this has changed, and this is a big thing, because what it means is that there are types of research being done at companies which will not be done in, let's call it the public sector, like by academia or whatever. This means that the intuitions of people are not going to be well calibrated. You're not going to get the best minds working on it. And you're going to see this kind of gravitational pull effect where it's going to make it easier for the private sector to pull people out of public science because they're saying, oh, you want to do this type of research, come and access the thousands of GPUs that you need to do that.
And you'll still have some time to do that. I mean, I think we've seen that with autonomous driving, for example, machine vision systems for vehicles and being acquired by the likes of Uber and so on, out of universities.
But I think that this is a matter of, it's a huge problem confronting governments worldwide. Because if you are okay with this and you wind the clock forward on this, let's say that some of these techniques start to yield really transformative things. I'll give you an example. There's a technique called neural architecture search. So the way that this works is, instead of having a human being design a neural network architecture, which you can think of as like layering really weird looking Legos together.
Right, with lots of wires in between them, right?
Yeah. Like, it's like a Rube Goldberg machine from A Nightmare. Salvador Dali interpreted it, that sort of thing. You can now use AI to train systems to design architectures. And this is very, very expensive. It uses hundreds and hundreds of GPUs to do. But you now no longer need to have your human design the AI architecture. They can focus on other things. And this has already yielded systems that have the world state-of-the-art score on image classification. That's a system from Google that they called AmoebaNet, right? Because they're calling it Amoeba because they see this as kind of this organic, emergent type of system. And so as a consequence, when you think about the implications of this, you're going to deal with a world where governments are going to find that transformative AI capabilities will not come from universities, will come from the private sector. And that means that the private sector has more leverage with regard to governments and also government policy on stuff like AI. And I think that this is like systemic societal scale problem that we are not really acknowledging at the moment. And, you know, and I count myself as being one of the people here that's troublesome.
We are going to acknowledge this risk later in our conversation. So what I want to do is just keep us on the question of the technical capabilities and where things are getting to. I mean, neural architecture search was a great segue there. One of the things that I have found fascinating has been the level of complexity of the deep learning networks that have been developed over the last few years. I remember reading papers and back from 2015 and 16, and the complex networks might have had 50, 60 million different parameters that needed to be tuned in some way. And my sense is that the new complex ones need 1,000 times as many, maybe 1,000,000 times as many parameters to essentially optimize during that training process. So one open question, I suppose, is how far can we actually go with deep learning? I mean, is deep learning the path to artificial general intelligence? Or, as some people argue, do you really need to put in either prior knowledge or engineer particular features or architectures in the system? I mean, from the perspective of your community, what do you think?
Do you ever go walking? You personally?
Like in the woods, or
just for a stroll?
Yeah, I'm a stroller, and I'm a walk and talk meeting person as well.
Same, but you'll find yourself.
Oh, we did that, yes, in San Francisco.
We've done this.
Yeah,
done this a few times. Yeah. But when you're walking, right, you find yourself attending over the world. You'll see a bird, and you'll go and look at the bird, right, and you do all of this automatically. Now, that's not because you're that really intelligent. It's because you're running, we can think of as a pre-trained policy, which is for millions of years, creatures evolved. And if you weren't good at like spotting the bird in the tree, you died.
Right.
And you didn't get to like pass your genes on and such. So yeah, like humans are kind of impressive, but a thing to think about is that humans have been evolving for like millions of years, and we actually have a huge amount of knowledge baked into us.
Right.
So a thing that we talk about at OpenAI, Ilya Sutskever, who's a co-founder and was involved in the ImageNet breakthrough, talks about this, is maybe a good way to think about it is, yes, deep learning systems are very data inefficient, right? But maybe they're as data inefficient as like the course of human evolution,
right,
which gathered data over millions of years.
Fact, I suppose.
And then you're born, right? You, Azeem, are born, and you are automatically recognizing birds, right? And you did not learn to do this; it just sort of happens to you. So I think that when we think about AGI and whether deep learning is going to be a component or not, it seems highly likely that it will be some part of the component, because it gives us a generic way to learn over large amounts of data and have capabilities come out the other end, which you can sort of join together. Mm-hmm. Now, what's interesting to me is how we join these things together. I think that you saw a trend in the AI community a few years ago of saying, we're just going to learn everything. And that's actually changing because they're realizing that, whether it's like symbolic techniques or handwritten techniques, you need stuff to kind of wire these learned systems together. Mm-hmm. And I think that some of the complex aspects of the development of more general intelligences will be how we wire up these various capabilities that will probably come from deep learning and wire them into a system that is reflexive and like self-updating. And that seems to be some of the hypothesis that we and others have.
Just a reminder, this podcast is sponsored by Spotify. I'm a massive fan of the service, and I'm delighted that Spotify has now launched a podcast hub. This means you can find all the episodes of the Exponential View podcast there, launch the app, and search Exponential View. Now, back to our conversations. So in a way, we figured out how to learn part of the system, but actually learning, for example, the things that we hand code in a symbolic system, mm-hmm. which might be the nature of relationships mm-hmm. between entities and the classes of entities. We haven't found good ways of learning those things efficiently yet.
So we have, actually. We talked about language earlier.
Yeah, of course.
The glue scores include common sense reasoning. So there you've got fantastically done big deep learning technology operating over language. Out comes a capability that can do things like co-reference resolution, disambiguation of terms within sentences, mm-hmm. proper, even some competitive work on Winograd schemas, which are kind of phrase riddles that are meant to reflect like common sense reasoning. So that stuff's coming out. I think that what we're less sure of is how you stitch all of these systems together, because it's likely that the way you join them together will be somewhat elegant and somewhat simple. And I think those things are the hardest to invent, actually. Simple things seem to take a lot longer to invent than hard things.
There's something to think about there. Is it also in the sense that the Wright Flyer, which flew for the first time 115 years ago this week of our recording, didn't look at all like a sparrow?
Yeah.
I mean, when we think about how we map out the mind or things that are mind-like, they might have some similarities, but actually the underlying engineering doesn't really make that much sense. It reminds me of something that a couple of researchers did a few years ago when they put a 6502 chip in an MRI machine mm-hmm. to try to see.
Could a neuroscientist understand a microprocessor?
That was the title of the piece
and it was
of work.
Playing Donkey Kong.
Yeah.
And they were like, well, this part of the chip is the barrel sensor.
Right.
And it's completely absurd. Like, it's not how chips work at all. And they're sort of showing the fallacy of that analysis technique.
Yeah. So if we look at some of the state-of-the-art systems today, I mean, I think AlphaZero from DeepMind is a good one, and you could probably talk more about the OpenAI ones. Mm-hmm. It seems like it balances a number of different techniques and a particular overarching architecture. So you have a sort of a deep neural network here, some reinforcement learning here, some search techniques sitting over here, and you have to have those connected in particular ways in order to get the outcome. And so it's not as simple as we took a neural network and we ran some data and we fed it back its errors.
Yeah. one of the most humbling experiences I think OpenAI went through is starting a robotics project, which I think seasoned roboticists who may be listening to this podcast will probably be laughing hysterically about what I'm going to say next, which is we have a project called sort of GPR, General Purpose Robot, and there were quite ambitious goals about just how much of this we would use AI systems to learn. And I think what we've discovered as we've gone through that project is you need to build a heck of a lot of infrastructure around your robot to even be able to plug a learning algorithm in and have useful stuff start to happen. And I think that the AI community tends to underappreciate the stuff you need to build around the system to let it learn and is kind of over fond of the learned components. Maybe it's just because that's the cool thing that they work on and the stuff around the system seems boring. But what we're discovering is that these large-scale systems tend to have huge kind of support infrastructures built around them. And that complexity tends to be specific in the case of like some of the AlphaGo work and some of our own work. I think there's a bet that over time it can become general. Like you'll have a general infrastructure and then you drop in different learning components for different systems.
Well, I think the history of technical systems would suggest that is what would happen, and different people will pick off different parts of the problem to stitch together as a system becomes more and more mature. And so you'd have to be making a strong claim to say that AI is going to develop differently to PC motherboards or to laser printer systems or to the networking stack.
Yeah.
And that's quite a strong claim, probably not one we can make. And so what tends to happen is we tend to focus very much on the algorithmic breakthrough, the thing that has a benchmark against which you can shoot. And you guys have done this with Dota. Is that the video game? Is that the wrong thing for us to spend so much of our attention on when we think about the progress of the general systems level technical progress of AI?
I think that we should be performing more fundamental analyses of stuff like computation. I'll give you an example, which is OpenAI did this analysis earlier this year. If you Google AI and compute, you can find it. And what we did is we went through major research papers about AI systems like, AlphaGo from DeepMind, some of our own work on Dota, work on translation from Google, the original ImageNet paper. And we looked at the amount of computation that was used to train those systems. And what we discovered is over the past 6 years, the amount of compute used in training large-scale AI systems has increased by 300,000 times.
That's right.
That's a big number. Like Moore's law gets you 12x over 6 years. We think that this analysis has a lot of signal in it because what it tells you is that it speaks to the underlying industrialization of AI as a field of research. We're able to do that because people are attending to the importance of kind of computation. And by measuring this, which we get by sampling from a whole bunch of individual papers, we can get a sense of the overall progress in the field on one dimension. So I think that analysis is useful. But to your early question, I think we're always going to need simple benchmarks that we can use to motivate the development of specific systems, because frankly, it's hard enough to get anything done in the world. So you might as well give yourself like a simple goal to reach, and then you'll probably get there. And then what we're going to start doing is like stitching benchmarks together out of multiple ones, as you saw with the glue example, which I think is a fine way to go. The question for me is, and I'm curious what you think about this is what is the benchmark that society would like AI people to be pushing on? Because I bet it's not, we did really well on these Atari games from the 1980s, which is what AI researchers like to spend time on. They do that because it's a good metric. But I'm curious if there are better metrics we could have around things like healthcare or shared challenges that you could have people go after.
That's a really great question. And
what do you want us to measure?
Well,
tell us.
I think one of the things that's difficult is that it's quite hard sometimes to connect why a particular breakthrough is relevant. It's the constant Henry Ford problem of faster horses versus cars. So when you're getting excited and explaining to people about the breakthroughs in machine vision, it doesn't speak to them until you start to say, this becomes a superpower for an oncologist, or this will mean that there'll be more security around a particular installation. So connecting it back to the applications, I think, is a piece that is harder for people to wrap their heads around. Now, my own perspective is that the way we do this is by skilling up the wider public, skilling up people in business and in government and in education.
The wider public is 7 billion people.
Well, you start. Let's
be careful.
No,
here.
I mean, you start. I think you start somewhere. But but the trouble is, what is the new question of agency in the 21st century? And now, for many people, there are questions of do they really have agency, or even are they aware of the concept that they might have agency? Is still rooted in the things that mostly in some Western countries we've been able to get rid of, right? In certain sense of our own sense of personal liberty and personal standing. So in the richer countries, the new question of agency is, are you going to control the computer, or is the computer going to control you? And understanding that new world and the rules of that new world, which includes some of the technical capabilities, I think becomes quite important. So while I do think that having more benchmarks that seem a little bit more real world, which is why the Go benchmark was such a wonderful one, it's as incumbent on people who are working in other domains, in business and education, public policy, and so on, to start to equip themselves with what is really going on inside some of these AI systems and these machine learning systems, and understanding what those trade-offs inherently might be.
So I think I disagree with you here.
Oh, good.
Right?
That's
and
great.
I think you sound like a monk to me. You sound like you're saying these people outside this field must come to us and must learn our language so we can speak to them. I think I disagree. And I'm not meaning to
disagreements are great.
Mischaracterize your position.
Yeah.
But yes, it would be nice if these people learned more about AI, but they're very, very, very busy people. Like if I'm a doctor, is it now incumbent on me to go and learn about AI breakthroughs in radiology, or should I focus on being a doctor and healing people? I think that it's hard to go up to busy people and say, you need to learn about this because this thing is doing really interesting stuff. And I actually think it's more incumbent on the AI community to message out and actually create more information about what's happening, and go and meet these people where they are. Like go and talk to policymakers directly, go and talk to, doctors, DeepMind's doing this here in the UK with its work with the NHS, where it's actually going out to those communities. It hired a doctor who now works and sort of embeds with teams. I think that's probably the way that this happens. And therefore we need a sort of skilling up within, I think, the AI community about communicating about their own research and why they're doing it.
I certainly agree that any technical community that has a broad-based set of technologies needs to invest in actively designing with the human in mind, and having some principles and direction, intentionality of the way in which they want to design things. But I also believe that as we make this fundamental shift, that none of from the industrial society to the data, AI, intangible society, that we can't take the new infrastructure as a given. Nobody who's alive today remembers a time when the rules changed from being the rules of the farm to the rules of the factory and the city. So we're at an unprecedented moment. And so I think it's incumbent on people who are outside of the data and AI tech community to understand that there aren't really no rules, and they're going to have to be part of resetting that new set of rules, which is why, yes, maybe it's not all 7.5 billion, but people need to make strides towards getting their heads around the technologies and the maths and the systems questions. And we've seen some of this come through with the Facebook revelations in the last few months, and in particular when Facebook was present and not present in front of the British Parliament and a number of other parliaments. Many of the questions that were asked and some of the evidence that came to light was new, publicly new. but a large part of it had been known about for 5, 6, 7 years.
Yeah.
And in some sense, one has to say, well, what were the policymakers doing in 2011 or 2012 not to step in? And I think the reason they weren't was because they sort of felt, well, that's for someone else to worry about. And what I'm saying is, look, it's a phase change situation. None of us have been at a point where we've been rewriting the rules in such a wholesale way. We absolutely need to understand some of the core engineering, some of the core science, some of the core atoms and primitives in order to figure out the art of the possible, where the strains are likely to lie. And that's certainly, that's certainly the message that I take out. Now, I'm not suggesting that a judge is going to, win the glue challenge next year, and having been a, chancery lawyer for 30 years previously. But I am saying that it's not going to be enough for the nice man from OpenAI or Facebook AI research to show up and say, here's the algorithm that now does a better job of judging than you did.
I agree completely.
Dangerous agreement, always a bad thing.
I am concerned that we would be having the same conversation about globalization. Don't these people need to know about globalization arriving? Doesn't this person need to know that the flows of labor and capital are changing around them and we're building a new international consensus?
Well, but I think that's a great example because I think globalization is an absolute precedent for some of the technology backlash that we see. Because essentially we said globalization is going to be good for you. It's going to be good for everyone. And there might be some plates broken. But don't worry about the broken plate.
But I think we also said, I think that we would have also said it would be great if they familiarized themselves with some of the economic principles underlying globalization so they could make predictions about it, sort of as we're suggesting here with AI.
I think it's more about being able to communicate in two directions. So, and the globalization is a great one. So, example, one level of the communication is having your voice heard. And that, I think, is a critical part of any system where you want to have there to be accountability. But a second level of that globalization is that question is, can you also articulate, because you're on the front line, the realities of what is possible or where you see strain coming? So it's a little bit like I've actually hurt my shoulder and my elbow, and so I've been seeing the physio. And one of the things the physio has said is, to me, polished to myself, is you're really good at describing where your pain is because you seem to know your physiology and your anatomy a little bit. And many of my patients can't do that, and it makes it much harder. And I guess what I'm suggesting is that as we step into these questions, absolutely, people's emotions, their sense of unease or their sense of excitement should be part of the conversation. But it's also helpful if they can locate where that's coming from, which I think requires some technical understanding.
So I agree, but...
Good, but...
I think we need something else. And I'm going to give an example which will sound bad and will lead to bad implications. But
that's fine.
Let's go for it. You know about Edison and the elephant?
No, go on.
Edison electrocuted an elephant to prove that Tesla's ideas around electricity were dangerous. And I think it's an interesting example of how Edison went above and beyond traditional communication there. He killed an elephant with electricity. Like it was dramatic. It's lots of people. I think it happened on Coney Island in like 1901, 1902 or something. What I find motivating about that example is that's a case where a scientist and an entrepreneur also did something like deeply theatrical, right? And for a communication purpose. Now, in that case, it was basically to mess over a rival. So I'm not advocating we do that. I am advocating that people from within AI, and this is incumbent on me at OpenAI to think about what the theater could be, to wake people up in a really visceral way to what this technology is doing. Because I actually think if we explore big, crazy theatrical demonstrations, that might help us educate those 7 billion along with the experts.
Well, having theatrical, clear...
Oh, we don't... No plans to kill elephants. I want to be extremely clear about that.
Yeah. Surprisingly, I think things like AI for good, things that tie breakthroughs in machine learning and the application of that technology to some of these UN SDGs, Sustainable Development Goals, can be motivating for people. but I think we're sitting on twin challenges, right? So I think one of the challenges is that people are getting a little bit bored of the man from the technology company saying, "I'm here to help."
Yes, I'm Jack, and I'm here to help.
Yes, and then apologizing for not living up to their expectations.
Well, the patience has run out.
The patience is really running out, and I think the second issue is also just one about trust and power. It's always convenient for someone to say, "You don't need to know about this. I'm going to take care of it for you."
Mm-hmm.
I think one has to have an incredibly deep trust relationship in order to do that. When I think about the wider societal conversation about AI, I do feel that it's a good thing that there are politicians who are now capable of asking the right questions, whether it's Ted Lieu or Damian Collins in the UK, to start to ask the right questions, and that is an important part of creating the bridge. I mean, you're absolutely right. The community itself needs to build bridges outwards, from theatrical to humane to dumb down technicals. But I think it's helpful if the other side of the cliff builds a bit of a bridge as well.
I want those difficult questions from politicians, and I think we're getting close to a point where they're going to sort of wake up to this. You saw in the Facebook hearings and such that you're starting to see some of it. Some of the questions are a bit all over the place, but some of them are quite sophisticated.
They're getting there. Yeah. But the world is moving very quickly, as you said earlier. And I think this question around what is the policy, what are the policy prescriptions around AI is a very interesting one. The other one that's significant is the geopolitical question.
I mean, AI is a political technology. If anyone wants to avoid that is a little silly. What I mean by political technology is it's kind of a general purpose utility that you, say the state, can layer over anything, and you can augment anything with it, especially if you are a creator of systems, which governments are. Like, you run systems. Well, you can know nothing about what's going on in an individual system other than just the rate at which stuff flows through it, and then you can optimize that flow without knowing the underlying things. You see what I'm getting at?
Yeah.
So, like, if you're a government, AI is useful to you today in loads of like non-obvious kind of bureaucratic or dull ways. And so it's political in the sense that it will be used by governments in a major way to help them configure their states. And you see this, like, if you look at China is taking its particular brand of governance and control, and it's augmenting that with AI. It's scaling up its ability to monitor people. It's also like scaling up its ability to do pro-social things like work on medical care or healthcare. Then if you look at the US, well, because the US is like a market-based thing, it's not really using AI itself. It's using the market that it has control over to try and create AI winners, and also via legislation like CFIUS, which has blocked Chinese investment is trying to block Chinese investment into US technology, and an upcoming potential classification of AI under export control is trying to use that market system to go and like affect other people and block them.
Right.
And so when we think about the geopolitics of this, it's at once a useful technology, and it's also a technology that you use to kind of signal your intentions about your own kind of government to each other. And so anything that people do is kind of heavily politicized here. I think that the weirder implication of this is that, if you're Google or if you're Baidu or if you're like Element AI up in Canada or OpenAI, you should view yourselves as political actors whose effects have political consequences. Google's decision, if you can call it that, to not do Maven, which was a US sort of military AI project, has had dramatic second-order repercussions in geopolitics. It's changed the behavior of aspects of the US government, changed aspects of the US government's disposition towards tech companies in general, and then it's also being looked at from abroad as a justification for internal government investment rather than dependency on the private sector. So that one thing had a whole bunch of effects which are going to govern aspects of geopolitics.
One of the things that the AIs in the US are very, very good at is they're optimized at showing the ad that I will stick with, or the YouTube system's recommender is optimized to show me more and more sort of extreme, slightly more lurid content in order to keep me lingering on the site for a longer period of time. I mean, the design, the product design is attached to an overall strategic intent, and that strategic intent comes from the market culture or political culture of a given country. So it's very hard to see how you divorce the systems that you build from their political impact, and in particular, given the widespread awareness that we have of this technical infrastructure as sitting between us and the resources that we need to access. Perhaps you could have argued 15 or 20 years ago, if you were slaving away in some lab in New York during the midst of an AI winter, that you weren't doing that. You were sort of the keeper of the sacred flame, and no one believed it was sacred or indeed a flame.
Yeah.
But
the world's changed.
The world's changed. And, if you're an AI researcher or indeed anyone working in technology, you don't really have a strong argument to say, I didn't know I was building something that was political. I mean, it's on the cover of every newspaper ad nauseam.
So there's a book I want to plug here that I think everyone should read. Just everyone generically. It's called The Prize by Daniel Yergin. Have you read this book?
I'm writing it down.
You're writing it down?
I'm writing it down now.
It's a history of oil.
Yes.
And it's marvelous because it's also a history of oil companies. Right? One of the great anecdotes in The Prize is at one point, Standard Oil had a more sophisticated spy force from the US government because it needed to gather information internationally to plan its campaigns. And I say campaigns deliberately. Like it was a full-bore government-style entity, except it was within the US. And, once the US realized this, motivated an increase in investment in US government spying capabilities because they did not want to depend on Standard Oil for tips, obvious reasons. It also motivated changes in antitrust,
right?
Motivated the breakup of these big oil companies because the governments were like, we appear to have a company behaving like a government. This seems odd. No one elected this company. I think that where we are now in AI has huge parallels with this. Like the technology companies are developing capabilities that exceed those of governments. And the moment that the awareness of that reaches a certain point, the awareness of this is rising today around us, will trigger a huge political reconfiguration. And we're living in that time where the sort of pressure is building. My statements about us needing to think politically and think about the political question is I don't really see a scenario where we don't end up needing to have very hard conversations with a whole bunch of governments about who does what with the technology, why, who gets to do what, what's the law around it. And if we just continue to develop this technology, propose our own policies, but not make this investment into going out and talking to these groups, then the groups will just do what, the governments will do what governments traditionally do, which is that they just take control.
Yeah, well, and I think we face a slightly different picture depending on which company you are. I think if you're an established business with shareholders and you're already successful, Facebook is a good example, your ability to change is constrained by the fact that you've got to build up a culture with tens of thousands of employees. You've also got wealth. You've also achieved that by acting a particular way. And now the amount of humble pie you have to eat to change your behavior is probably more than your $41 billion cash hoard can buy. We have a precedent in the form of Microsoft, which,
went through that.
Took 10 years and 2 CEOs before it's now back once again the biggest technology company by market capitalization in the world, and is a very different business focused in a different sort of strategy. So the large companies, I think, will really, really struggle, and I'm curious about how that gets addressed. There are obvious ways in which they could potentially get broken up. There are different services, Google Maps, Instagram.
I want to give a brief shout out to Microsoft here.
Yeah.
A shout out to Microsoft is a phrase I never thought I'd utter in my life.
No, that's as a former technology journalist, you were still playing with Clippy.
Yeah, very strange.
Yeah.
They recently called for, in the US, the government to regulate facial recognition.
That's right.
They've called for that in a couple of blog posts. Now, a cynical reading of this would be they're calling for that because the US policymaking infrastructure isn't really going to do anything about it.
Right.
But this is an area where I'm not cynical. I think that the fact that a publicly listed company has sought to publicly say, this is a giant problem and we should not be the only person deciding how to deal with it is meaningful. And so I think that the big companies maybe there's leverage here for them because they can win trust of the public by doing this.
Yeah.
I think that smaller companies, it may actually be a really tricky thing because if you're a startup, you just need to make money and not die. You really shouldn't have to think about myself as a geopolitical actor in the 21st century. That seems like an awful burden.
I think some big companies are more well configured. Microsoft, because of its maturity and the fact it's been through this decade-long turnaround. Apple,
Bitten once, twice shy.
Yeah, Apple, because it hasn't had to rely on data as much. But the two big ones, Google and Facebook, I think will have cultural and momentum problems in trying to figure this out. Now, to your point about small startups, of course, they don't think about policy early, although they're hiring policy people earlier than ever before. But they do have a chance of building in this new world in the right kind of way. It's been fantastic to have you. We're going to have to continue this conversation, maybe in episode 2, and we won't leave it a year. Jack Clark, thank you very much.
Thank you for having me.
Thank you for listening to the Exponential View podcast. If you are new to this podcast, subscribe to receive more episodes each week. In the meantime, you might want to go to the archive and check out our previous episodes. To stay in touch with me, best subscribe to my weekly newsletter at exponentialview.co. That is exponentialview.co. The Exponential View podcast is hosted by Azeem Azhar and produced by Maria Gavrilov. Nasos Papadopoulos is the audio engineer and Boyan Sabiacello the sound editor. The Exponential View podcast is a production of E⁻I+1 Limited.